Hello and welcome everyone to my channel. It is me Siddharth sir, and from today I'm going to bring you a video series on the difficult identities that you prove in trigonometry on the chapter multiple angles, which is usually asked in 4 marks in the SE examinations. So the question for today will be shortly on your screens. So the question for today is, you'd need to prove that root 3 cosec 20 degrees minus sec 20 degrees is equal to 4. So we take the most complicated hand side to start the question off. And for this question, it is undoubtedly the left hand side. So whenever we take the left hand side into account, let's change all the trigonometric ratios in the form of sine and cos. So the question is given in terms of cosec and sec. Let's change that into sine and cos. So root 3 divided by sine 20 degrees minus 1 divided by cos 20 degree. So in the next step, I take LCM and I write down root 3 cos 20 degree minus sine 20 degree divided by sine 20 degree into cos 20 degree. So now, since I need to get 4 on the right hand side, I choose to multiply both the numerator and the denominator by 4 here. So I do that just to make sure I have some part of my answer already there. So this 4 on the numerator will be now kept aside, and I will be only using that in the fag end of the identity. So I keep the 4 aside, and the remaining term is written as 4 into root 3 cos 20 degrees minus sine 20 degree divided by 4 sine 20 degree into cos 20 degree. So I just move the 4 in the numerator aside. So in the next step, the 4 in the denominator is now changed as 2 into 2, just to make sure I have 2 sine 20 degree into cos 20 degree here in this step. So I did that only because I wanted to change 2 sine 20 degree into cos 20 degree as sine 40 degrees. So in this step, I have 4 into root 3 cos 20 minus sine 20 divided by 2 times sine 2 times 20 degree. So this actually happens because 2 sine theta into cos theta, or 2 sine A is 2 sine A into cos A will be sine 2A. So in this step, 2 sine 20 degree into cos 20 degree can be written as sine 2 times 20 degree. So this now becomes 4 into root 3 cos 20 degree minus sine 20 degree divided by 2, which was already there, and sine 2 times 20 degree becomes sine 40 degree. So in the next step now, I do a little bit of rearrangement here. So in this step, I write down the 4 as it is. This 4 is just written as it is. The remaining terms, root 3 cos 20 minus sine 20 divided by 2 is written inside the big bracket, where this sine 40, which is there in the denominator, is written as into 1 over sine 40 degree, because I do not want to change any of this. So the thing which is inside the big bracket now is subject to change now. So in the next step, if you can see my screen, so 4 into root 3 cos 20 minus sine 20 by 2 into 1 by sine 40 is there. So I'll be only working with the term which is inside the big bracket here, which is root 3 cos 20 minus sine 20 divided by 2. This 4 is my answer. I need to get this 4. So if I could cancel by simplifying whatever is inside this big bracket by sine 40, so if I would be able to cancel this sine 40, then I will be eventually getting my result, which I was trying to get from the outset. So this 4 is left as it is. This 2, which is dividing the whole term in the numerator, root 3 cos 20 minus sine 20 divided by 2, this 2 is now separated and divided. So root 3 cos 20 by 2 minus sine 20 by 2 is separated. Now with a little bit of reshuffling here, root 3 by 2 into cos 20 minus 1 by 2 into sine 20 is written here. So after this, what I do is I will now write down root 3 by 2 as sine 60 degree, because the value of sine 60 is root 3 by 2. It was not necessary to interpret this as sine 60 only. I could have written this as cos 30 as well, but I wanted to make a sine into cos kind of a relation here, because I need to make this as sine 40. because if I get sine 40 from this term inside the bracket, I'll be able to cancel it with this sine 40, which is lurking in the denominator. So in order to do that, I try to write down root 3 by 2 as a function of sine. So I wrote down that as sine 60 degree. And likewise, this 1 by 2 over here can be written as cos 60 degrees. Sorry. So if I write down these two terms, these two numbers here, root 3 by 2 and 1 by 2 as sine 60 and cos 60 respectively, now I have 4 into sine 60 into cos 20 minus cos 60 into sine 20 over here. So if I look at this line over here, this term inside the bracket over here, it resembles to a formula that we study in grade 9 in the compound angles. So if you look at it properly, it can be written as sine A cos B minus cos A sine B. So in the place of A there's 60, in the place of B there's 20. So I can write this as sine 60 minus 20. So if you look at the formula on the right hand side, sine A cos B minus cos A sine B is termed to be sine A minus B, and this is the formula of compound angles which we study in grade 9. So sine A cos B minus cos A sine B can be rewritten as sine A minus B. So in the place of A and B we have 60 and 20 respectively, so we write down sine 60 into cos 20 minus cos 60 into sine 20 as sine 60 minus 20. So after we do that, 60 minus 20 becomes 40. So 4 into sine 40 into 1 by sine 40 it comes over there. So we can now cancel the term in the denominator and the numerator because it's the same term, which is sine 40 degree, right? So 4 into sine 40 into 1 by sine 40. Now sine 40 and sine 40, they neutralize each other. So now we have only 4 into 1 remaining, which is actually 4. So this 4 was our right hand side, and this will help us prove the given identity. So hope you all enjoyed the video, hope you all understood the video, and I'll be coming back with some more videos in the days very soon. Thank you everyone. Have a very good day.